What's up, people? Welcome to the session. How is everyone doing? My name is Anoop and this is Vedantu. I hope that all of you guys are, giving your best for your preparations. I'm back with another video of Sprintex ICSE 10th. Today we'll be talking about refraction of light at plane surfaces, session number 2. So in the last session we had actually done pretty much half the chapter, but we are left with the rest of the chapter, that is total internal reflection and total internal reflection through prism, refraction through prism, factors affecting angle of deviation and all of that. So we'll be talking about those chapters, those topics. We'll be solving questions from those topics alone. So if you haven't watched the previous video yet, please make sure that you watch that as well, because that will give you an idea of what we had done in the previous session, so you'll understand that what we're going to do today. So basically it's a continuation of the previous session. So we've done all these 3 topics in the last session. Today we'll be doing the rest of it. So this is the schedule, people. First of all, before we go any further ahead, hit that like button, subscribe to the channel, because we're coming up with a lot of videos like this to help you guys out, to help you do better in your exams. As you guys know, Sprintex series is one of our all-time favorites. It's been going on for a long time now, which will help you guys to understand what kind of questions can be expected from your board exams, and how do you tackle those kind of questions, and how do you take the least amount of time to actually solve these questions. Also, we'll be tackling all these problems at once. So we had started with fourth chapter. So make sure that you watch all those previous videos as well. We'll be going on till 26th of Feb, wherein we'll be doing radioactivity as well. For biology, it's taken up by Ambika ma'am. It has already started from cell cycle and cell division. It will go all the way to endocrine system, again till 27th of Feb. Chemistry is taken up by Anoop ma'am. It starts from, it has already started again. Periodic properties and variations was the first session, and it will go on all the way till organic chemistry. English is taken up by Shweta ma'am. Starts from Merchant of Venice, goes all the way to My Greatest Olympic Prize. Again, 27th of Feb is the last day where you'll see the end of that English series as well. SST again taken up by Ankana ma'am, starting all the way from the Indian National Movement. It'll go on all the way till interpretation of topographical maps, again till 27th of Feb. And finally math by our very own Gopal sir, starting from GST, going all the way till probability till 26th of Feb. So make sure that you subscribe to the channel, because all these amazing content is coming your way. So do not forget to hit the like button and subscribe to the channel. It'll all be there in the community page. You can always also download these notes at any point of time, so you'd never have to worry about anything. So that's it, guys. Let's commence. Let's start with the very first question. But before we get into that, guys, I actually asked you homework in the last session. This was the question: a ray of light is incident as a normal ray on the surface of separation of 2 different medium. What is the value of angle of incidence in that case? So the question was basically like this: if the angle of incidence is basically if the ray of light is incident normal on the surface of separation, let's say this is air and this is water, what would be the angle of incidence? The angle of incidence would actually be 0 degrees, because what is angle of incidence? It's the angle between the normal and the incident ray. So if the angle of incidence is exactly on the normal, what's the angle between them? 0 degrees. So the answer to this question would be 0 degrees. So these are the homework rockers that got it right. We have Nitya Gya, yes buddy, I do remember you, Swati and Jaskirat and also Mohit. Awesomely well, guys, awesomely well. Keep up the good work. So if you want your name to be here next time, make sure that you answer today's homework at the end of the video in the comment section, right? So with that said, let's begin without wasting any more time. The first question is taken up from a very recent question paper of yours, 2019 board. The question is very simple. It is a 2-mark question. You can take up to 2 to 3 minutes in your exams, but we'll try to do it in one, right? The question is this: define what is critical angle. State one important factor which affects the critical angle of a given medium. So let me just write it down, people. So I'll try to write it as soon as possible. My handwriting is a little clumsy, so please bear with me. Don't worry, anyways, you can download the notes, so all the printed notes will also be there. So don't worry about it. What is critical angle? Critical angle is that angle of incidence. It is that angle of incidence in the denser medium. In the denser medium, when a ray of light is going from denser into a rarer medium, where the angle of refraction, will be equal to 90 degrees. That is what is critical angle. So that angle of incidence in the tensor medium where the angle of refraction is 90 degrees or normal or is passing exactly on the surface of separation, that is what is called as your critical angle. State one important factor that affects critical angle. There are several factors. Wavelength of light. It depends on the wavelength of light. It depends on the wavelength. It depends on the refractive index of the medium. The refractive index of the medium. It also depends on the the material itself. So that is basically the refractive index itself. So it depends on all of these factors: wavelength, refractive index, even the temperature also. It also depends on the temperature as well, right? So it also depends on the temperature as well. So all of these are the factors that your critical angle depends on. So here they've given us the nature of the two mediums in contact, which is nothing but you can talk about the refractive index itself. That tells you what is the type of what is the nature of the medium. Now again, you have to make sure that if you want to see the angle, the incident ray should be going, the ray of light should be traveling from denser medium into a rarer medium. Only then you'll be able to see this. Otherwise, it will not happen. Alright, that is one thing that you have to remember. Anyways, so that is the answer for that question. Board exam 2019. 2-mark question. With the explanation, it would have taken me 2 minutes. Without the explanation, that's 1 minute. So that's done. Moving on to the second question, guys. Here's another one. And this is a rather interesting question. All right. I found this question very fascinating. All right. The question is this. It's a 2-mark question taken from 2019 board exam again. 2 to 3 minutes. We'll try to do it in one. All right. Probably might take a little longer than one because to draw. Yeah, my drawing skills are next level. Anyways, the question is this. The diagram below shows a light source P embedded in a rectangular glass block ABCD of critical angle 14 degrees. Complete the path of ray of light PQ until it emerges out of the block and write the necessary angles as well. This is an amazing question. Trust me, this is one mind-boggling question. All right. So let's try to do this. All right. Do it with me. Now, here they've told you that the angle with the prism, the ray of light, the incident ray, which is making an angle with the prism, is 42 degrees. So if I were to draw a normal over here, all right, if I were to draw a normal over here, what would be the angle of incidence? This is the angle of incidence. So we'll call this, okay, yeah, it is called as Q. So let's call it as Q itself. So what would be the angle of incidence? The entire angle is 90 degrees. And that angle between the prism and the triangular prism or the surface and the light ray is 42 degrees. So what will this angle be? This will be 48 degrees, and obviously 90 minus 42 it will be, which is nothing but 48 degrees. That is what you're going to get. So this angle is 48 degrees. Now, the critical angle of the prism has given us 42 degrees. The angle of incidence is 48 degrees. So what do you think will happen? If the angle of incidence is greater than critical angle, total internal reflection will happen. So what will happen? Exactly at 48 degrees, again this ray of light will get reflected back. So get reflected back at 48 degrees itself. So what is this angle? This angle will also be 48 degrees. Right? We've already seen that. Your first law of reflection, that is angle of incidence will always be equal to angle of reflection. So the angle of incidence is 48 degrees. The angle of reflection should also be 48 degrees itself. Now, here's the catch. This angle is 90 degrees. This angle is 90 degrees. This angle here is 42 degrees. Again, why 42 degrees? Because the entire angle is 90 degrees. This is 48, so that will be 42. So what will be this angle then? What will be this angle? 42 plus 90. Basically, it's a triangle. So QC, let's call it as F. Let's call this as F. So what is triangle? It's basically a triangle, right? It's triangle QCF. So QCF, if you know, if you guys already know that the sum of all the angles in a triangle is equal to 180 degrees. So we have one angle is 90 degrees, the other is 42. Minus 180 will give you what is the angle, or we'll call it as, okay, we'll plus angle F. Angle F is equal to 180 degrees. All right, so we'll leave it like that itself. So 90 plus, so this will be what? Angle F is equal to what? 180 minus 90 plus 40 degrees, 42. So now what will be the angle? I think it will be again, it will be 42 degrees itself. 90 plus 42 for 90. Okay, that's 132. 132 minus 180. Again, I think it will be 42 degrees itself, right? I believe it will be 42 degrees itself. All right. Yeah, that's that. Okay, that angle is also 42 degrees. This angle is 42 degrees. All right, this angle is also 42 degrees. Now, again, if you were to draw normal to this particular and that particular incident ray which is incidentting on the surface CD now. If that is 42, this will be what? This will be 48 degrees. This will be 48 degrees now. Now, once again, what will happen is that this is the, wait one second. Yeah, this is the angle of incidence. So what will happen this time is that the ray of light after reflection, basically, wait a second guys, one second. The critical angle is 42 degrees. Wait, what? No. Okay, this angle is 48. It is not 42, it's 48. It's 48. Sorry. This will be 48. The angle of incidence will be 42 degrees. Alright, so let me just correct that, guys. Calculation mistake. Blunders. This is definitely more than 1 minute. But yeah, I'll have to explain this because it's a very important problem. So this 42 plus 90 is 132. 132 minus 80 is 48. Yeah, it's 48, not 42, it will be 48. So this will be 48 degrees, right? So if this is 48, this will be 42 degrees then, because again 90 minus 48 is 42. So this will be 42. So the angle of incidence of the second surface is 42 degrees. So what will happen? It will basically it's basically hitting at the critical angle. So when the angle of incidence is equal to critical angle, the angle of refraction will be equal to 90 degrees. So the ray of light would pass through on the surface of CD. Yeah, this would be the answer, guys. This would be the answer for this question. It's a pretty easy diagram, but then again to explain it, it might take a little longer. So you have to understand why you got 42 over here. The reason why you got 42 is because this is a triangle. This is 42 degrees again. This is 90 degrees. So this will be 48 degrees. Then the other angle will be 42. That's all. Voila, people. Definitely that took about 2 to 3 minutes. I accept it, but yeah, I had to explain it, guys. If I had to draw with a scale and pencil, that would have taken so much time. But yes, again, to explain it, it might take a little longer. Alright, another question. Again, it's a recent question paper, 2018 question. It's a 2-mark question again. In your exams, 2 to 3 minutes. We'll try to do it in one. The question is this: state the relationship between the critical angle and the absolute refractive index of a medium, and which color of the light has a higher critical angle, red light or green light? Beautiful question. It's actually a very, very simple question. For the first part of the question, what is the relation between critical angle and the absolute refractive index? Critical angle of a medium and refractive index, the relationship is that the absolute refractive index of a medium is equal to 1 by sine C. 1 by sine C, which is nothing but sine of the angle of incidence, which is nothing but the sine of critical angle. Second part of the question, so this is the relation between the critical angle and absolute refractive index. Now to talk about which color of light has a greater critical angle, it would be red light. Why? Because the wavelength of red light is more, so the critical angle would also be more. Green, on the other hand, has a lesser wavelength, so the critical angle is going to be less. That took 30 seconds, alright? So we made up for the time that we lost in the previous question. So that took 30 seconds. So that is the end of this question as well, people. I hope you got it right. Now I want everyone to do it with me, guys. I know I might be talking a little too fast and solving a little too fast. So what I want you guys to do, what I expect from you people to do, everyone who's watching the video right now when it's getting premiered, and the people who are watching the video later on as well, make sure that you pause the video for a second, take a minute break, pause the video, do the question by yourself, and then check out the answer, or compile the answer. That way you will be able to practice it better. It's a good practice for you guys, so that you can get better every single day, right? Anyways, this is the next question. It's a 2-mark question taken from 2013 board. It's a very simple question. 2 to 3 minutes. We'll try to do it in one. The question is: a coin placed at the bottom of a beaker appears to be raised by 4 centimeter. So they're talking about the shift here. Shift is given as 4 centimeter. The refractive index of the medium is given as 4 by 3. The refractive index of water is given as 4 by 3. Find the real depth of the water inside the beaker. It's a very, very simple question. In fact, you can directly use the formula over here. Shift is equal, if you remember the formula, shift is equal to real depth into 1 minus 1 by mu, or the refractive index is the formula. Directly put down the values and find the answer, guys. If you don't want to do it this way, you want to do it the manual way, you want to do it in another way, you can do it that way also. That is, basically, tell the refractive index is equal to, it's nothing but real depth by apparent depth. You can use this formula again. Then we also know that shift is equal to real depth minus apparent depth. So solve for apparent depth or real depth any one of the unknown values and then substitute in the shift wala equation, you'll again end up getting the same thing. But if you don't want to remember the formula and you want to go the long way, that is up to you. But at sprint X, we'll try to do it as soon as possible. So we'll directly put on the formula over here. So real shift is given as 4, real depth is given. We do not know the real depth, so I'll take it as RD over here now. So 1 by 1 minus 4 by 3 is what you have. So real depth into 4 minus 3 by 4 into 4, so which is nothing but real depth into 1 by 4 into 4. So real depth is equal to 4 into 4, which is nothing but 16 centimeter. Voila, that's all guys. Direct formula, direct substitution, and get the answer. That's all. The answer is 16 centimeter. It's as simple as that. Alright guys. Anyways, before we go any further, if you guys are enjoying the session, in the chat box, give me a bazinga. If you guys are enjoying the session, give me a bazinga. And yes, people, hit that like button, hit that subscribe button as well. And also, if you want to be a part of us and want to have a lot of fun like this and score a lot of marks and gain 100% knowledge in every single topic that you have in your boards, all you have to do is click on the link that is given in the description as well as the pinned comment section. Now, before you get on, get on to close the video, before you decide to click on the link, let me tell you what are the advantages. Before you make a decision, just listen to me for another 5 minutes. Here's the thing, guys. First of all, we at Vedantu are giving you unlimited live session. There's no limit as to how many number of sessions you want to take. There's no limit. Nobody's going to set the limit. Neither me, nor Vedantu, nor your parents. It's you who's going to decide how many sessions you want to attend in a day. And every one of those sessions are going to be fun-filled, and all of those sessions will have highest level of quizzes, which will ensure that you're not only learning, you're also having fun, and you're also having a chance to apply the knowledge that you just learned or just acquired. And this quizzes also gives you an opportunity, a unique opportunity to compete with the rest of the world and see how good you are in that particular subject, because you don't have students from your class or from your school or from your district or even your state. It's from the entire country, in fact the entire world. So you have an actual opportunity to compete with the rest of the world and see how good you are in that particular subject. With that, people, even if you miss out a session, don't worry, because even when you're watching the replay sessions, you can actually take the quiz right there and then and still check out the leaderboards while you're watching the session. So you have an unlimited option to improve yourself every single day. Check out the quizzes again and again and again if you want to, and make yourself better every single day. With this, people, you have an opportunity to come download all the premium content, every single handwritten note, every single recording of every single session, so you never, ever miss out on anything that is important. Everything that is important would be covered right there and then. And you can download it, watch it, make notes out of it, whatever that you want to do with it, it's up to you, people. With this is one of the best parts, I would say, is that inside the live sessions, you will not just have the master teacher to help you clear your doubts. No. With the master teacher, you will also have the class teacher to help you clear every single doubt of yours. The class teacher will ensure that all your doubts are cleared right there and then. Even if it's 50 doubts, even if it's 100 doubts, it does not matter. All your doubts will be cleared right there and then itself. And yes, for all those people who are looking around right now for your sample papers and question banks and all that, you don't have to run anywhere, guys, because we have some amazing tests and assignments also planned for you guys. So all these tests and assignments, the questions taken from them are from your previous year question papers, from your sample papers, from your ISOs, NSOs. So all kinds of good source of questions have been taken up and have been tailor-made so that you can make yourself better every single day. So it's like a one-stop shop for everything that is related to your preparations of your exams. With this, as I always say, like a sprinkle on top of a chocolate sprinkle on top of your vanilla ice cream, 5,000 plus micro courses and crash courses, all for free. Right. All you have to do is, guys, again, click on the link that is given in the description as well as the pinned comment section. And yes, people, since this is Valentine's Day, for today, only till today, that is till 12 p.m. today, you have an amazing opportunity to get 50% discount on the courses that are offered. That is up to 1,500 rupees off on the courses. Let me tell you why that makes a huge difference. So the 1 month program, basically the base price of that is around 2,699. But only for today, if you use the coupon code AME Pro, the coupon code is AME Pro. If you use the coupon code AME Pro, you get a discount of 50% and the price drops down to 1,349 rupees and 50 paise. Now you might be still thinking, sir, 1,300 rupees, like what is the value I'm getting out of it? Think about it, people. In that 1,349 rupees, in that 1 month duration, you would have attended a minimum of 200 sessions, minimum. 8 subjects, a minimum of 200 sessions. That means that per session you're paying about 6 rupees 7 paise. That's all is what you're paying per session, which is less than a packet of Lays that you pay 20 rupees for, right? Link in the description. Coupon code is AME Pro to avail the discount. Check it out. It'll be there only till today, and after that again it'll go back to the normal price. So make sure that you click on that link and check out the link, check out the coupon code as well. Alright. So that's it, people. Let's get back to the question. The fifth question for the day. It's a 3-mark question taken from 2019 board exam. So let's try to solve this one as well. 3 to 5 minutes is the time that you can take in your exams. We'll try to do it in 2 minutes. The question is this: how does the angle of deviation formed by a prism change with the increase in the angle of incidence, and draw a graph showing the variation in the angle of deviation with the angle of incidence in a prism surface? An awesome, super awesome question, has been asked so many times in the previous years. You can check out your previous year question papers. This is one question that has been repeated one of the most number of times, so make sure that you know the answer for this one. Now, to answer the first part of the question, how does the angle of deviation formed by a prism change with the increase in the angle of incidence? As you increase the angle of incidence, the angle of deviation, or the angle of deviation that is there, will actually, sorry, the angle of deviation is represented, angle of deviation would actually decrease. Angle of deviation will actually decrease. So if you increase the angle of incidence, the angle of deviation would keep on decreasing. Now, the graph is basically a very, very simple graph. All right. So this is the graph. So you have on the x-axis, you have angle of incidence. So this is the angle of incidence, which is represented by I. And this here is the angle of deviation, which is represented by delta. So yeah. What is the graph basically looks like this, all right? As you increase the angle of incidence, the angle of deviation keeps on decreasing. Once it reaches the minimum value, which we'll call it as delta m, all right, that is the minimum value of angle of deviation. Once it reaches the minimum angle, what happens then? As you increase the angle of incidence, after you reach the minimum value, the angle of incidence, angle of deviation actually keeps on increasing. So the graph actually looks like a curved graph. So when you increase the angle of incidence, the angle of deviation keeps on decreasing. But once it reaches the minimum value, what happens is that when you keep on increasing the angle of incidence still, instead of decreasing, it'll increase suddenly. So it'll keep on increasing with the angle of incidence. So this is the graph that shows it all. So this is what the graph looks like. This is the angle of deviation, this is the angle of incidence. So if you were to increase the angle of incidence, the angle of deviation would actually become less, or it decreases until it becomes a minimum value. Once it reaches the minimum value, then it'll keep on increasing. Right? That's the end of the fifth question, people. I don't think that took even 2 minutes, but yeah, that is an easy 3-mark in your pockets. Please remember this. It's a super duper important question. I'm going to mark it as super important. It's very important, so make sure that you remember this. All right. Moving on to the next question. This is the sixth question for the day. Let's try to do this as well. A ray of light XY passes through a right angle isosceles prism as shown in the figure. What is the angle through which the incident ray deviates and emerges out of the prism? Name the instrument where the action of prism is put into use. Which prism surface will behave as a mirror? Whoa, it's an easy question. Trust me, it will take you 30 seconds to solve this question. 30 seconds is all it takes to solve this question. So it's a board exam 2018 question, 3-mark. It doesn't even take 30 seconds. All right, first question. What is the angle through which the incident ray deviates through? It is deviated by an angle of 90 degrees. You see this? This is the incident ray. This is where the ray was supposed to go. But what happened? It got deviated by an angle of 90 degrees. So that is the answer. Second part of the question. Name the instrument where the action of prism is put into use. It is used in your periscopes. In your periscopes, we use this because instead of using mirrors, we place it exactly at 45 degrees, and we incident the light. So it's used in periscopes, which is used in your submarines and tanks and all of that. Right. The third part of the question: which prism surface behaves as a mirror? The surface AB. AB is the one that behaves like a mirror, right? Because this is the one that it's a prism. It's supposed to be a transparent material, but then because the angle of incidence is greater than the critical angle, you are able to see total internal reflection, which happens at the surface AB. 30 seconds, guys. 30 seconds is all that it takes to answer this question. Easy 3 marks in your pockets. Please don't make mistakes in all of these. Don't. That you're going to regret it. Trust me, you'll regret it if you guys make such silly mistakes. Alright, for these kind of questions, don't make mistakes. Next question, 7th question. I hope you guys are doing with me, people. Pause the video if you want to take a break and do it with me again. The question is taken from 2018 board exam. It's a 3-mark question. 3 to 5 minutes is what you can give your exam time, but then we'll try to do it in 2 minutes. The question is, draw the diagram of a right angle isosceles prism which is used to erect an image. Now, the thing is this, guys. You can do 2 diagrams to actually show this. Alright, I'm going to draw both the diagrams, so it might take a little bit more than 2 minutes, but I'll try to draw both the diagrams. Alright, the first diagram is going to be like this. This is my isosceles prism. So an isosceles prism has 2 angles to be equal, and the one angle is at 90 degrees. So here we have this is 45 degrees. This is also 45 degrees, and this here is 90 degrees. Alright, this is 90 degrees. Alright, now listen carefully. One ray of light, let me just show it with a different color. One ray of light comes in incidence exactly normal to the surface. When it's incident normal to the surface, what will happen? It will pass through undeviated. It will go and incident on the surface at an angle of 45 degrees, which is greater than the critical angle, because critical angle of a prism is of glass is 42 degrees. Greater than critical angle, so what will happen? It will get reflected back. Total internal reflection. Once again, it will come and incident on the surface. The angle at this surface is also 45 degrees. This is also 45 degrees. This is also 45 degrees. This is also 45 degrees itself. So what will happen? Again, total internal reflection, and it will basically come through. So let's say that the object is placed like this. This is the object here. One more ray of light. Again, the same thing happens. Total internal reflection. And yes, you see that the image is inverted. Now, if the image is already inverted like this, then the image will become erect. All right. Now, there are 2 things about this prism. All right. This arrangement of the prism. There are 2 things. One is that here the image is getting deviated by 180 degrees, like this one. You see this? It's getting deviated by 180 degrees, and it's also getting inverted. Another diagram that you can do is basically this one. So in this case, you see this. This is the this is the prism. So I believe that again, this is 90 degrees. This is 45. And this is 45 if I'm not wrong. I might be wrong about the angle of prism. Basically the placement might be a little wrong. Please check that out. But yeah, it's like this itself, right? It's more or less the same. So one ray of light comes and hits on the surface. It's not normal to the surface. So what will happen? Refraction, come and hit the base, gets reflected back, and then again passes through. One, let's say there's an object which is inverted already. One more ray of light, again refraction. Alright, let me just erase that. That's horribly bad. My diagrams are bad, guys. So don't worry. Again, you can download all the images, so don't worry about it. But just in case, I want you guys to know how to do it. That's all. So this is how the image would look like. Now, in this case, there is no deviation whatsoever. It is just getting inverted. So you can do both of these ray diagrams. It does not really matter which one you do. It's totally up to you guys. You can totally do both of these ray diagrams. It's up to you people. All right, so make sure that you choose one and do it accordingly. All right. So that is the answer, guys. So here it is. So this is the prism that we just talked about before. So yeah, this is correct. This is 45. This is also 45. Here is 90 degrees. So this is correct. And the other one is not given over here, but yeah, you can refer the textbooks to get the ray diagram of that one. Right. Okay. So that was a pretty, that was more than 2 minutes, but still it was worth it, right? Moving on to the 8th question, a 5-mark question, people. This is an easy peasy question. 2017 board exam, 5-mark. 5 to 8 minutes. We'll do it less than 3 minutes. Trust me, it won't take more than 3 minutes. Alright, the question is this. A ray of light travels from water to air, so from a denser medium into a rarer medium as shown in the diagram. Copy the ray diagram and complete the path of light. Given that the critical angle of water is 48 degrees, state the conditions so that the total lateral reflection occurs in the above diagram. Such an easy peasy question, guys. Now, they've already given that the critical angle is 48 degrees. If you look carefully, the angle of incidence is also 48 degrees. So what will happen to the refracted ray? The refracted ray would actually pass on the surface of separation itself. So the angle of refraction would actually be 90 degrees. This is the ray diagram. This is it. That is the ray diagram. It's a 5-mark question, guys. 5-mark question. It's an easy peasy question. Now to answer the second part of the question, state the conditions so that the total lateral reflection occurs in the above diagram. So what are the conditions? First condition is that the ray of light should go from denser medium into rarer medium, denser to rarer medium. This is the first condition, which is already satisfied. The second condition is that the angle of incidence should be greater than the critical angle. Oh my god, what was that? Okay, that was weird. Alright, it should be greater than the critical angle. So that is it, people. So here, so if you increase the angle of incidence in this case, you will be able to see total lateral reflection. So if you increase the angle by, let's say, instead of 48 degrees, if you make it 50 degrees or something, then yes, you'll be able to see total lateral reflection, right? So if you want to draw that also, you can draw like this. So imagine that this is 50 degrees now. So you'll be able to see total lateral reflection. That's all. Voila. 5-mark question, guys. 5-mark question. 2017 board exam. Jujube question. The answer of the angle of incidence should be greater than the critical angle. That's it. Alright, one more question. This is not the 8th question. This is the 9th question. Again, a 5-mark question. 5 to 8 minutes. 2017 board exams again. 3 minutes. Trust me, it won't take so much time. Let's go ahead and do this, guys. The question is this. The diagram below. Alright. Oh my god. Okay. Wait, what? I think this is the same question, no? I believe it's the same question. Oh yeah, it's the same question, guys. It's not the 9th question, right? So yeah, it's actually this question is actually pretty long. I didn't realize it until now. All right, so this is the question, guys. This is the second part of the question. The diagram below shows a point of light source P inside the water container. Four rays A, B, C, and D starting from the source P are shown up to the water surface. Show in the diagram the path of these rays after striking the water surface. The critical angle for air and water surface is 48 degrees. Name the phenomena exhibited by which the rays B and D exhibit. It's again, this is 2 marks and this is the rest. I think the diagram would give you 2 marks. And the last one maybe would give you another 1 more mark. So let's try to do this, guys. It's a very simple question. So there are 4 rays of light, all starting from the point P. The critical angle is given as 48 degrees. You have to show how does the ray of light react, or what happens to the rays of light once they hit the surface of separation, and also name what is the phenomena the rays of light B and D are exhibiting. Again, it's the same question. So for the first one, it will pass through undeviated because the angle of incidence is 90 degrees, so what will happen? It will pass through undeviated. Angle of refraction. So angle of incidence is 0 degrees over here. So the angle of refraction will also be 0 degrees. It will pass through undeviated. For the second one, there will be some refraction. It's going from a denser medium into a rarer medium. So it will go away from the normal. So you'll be able to see a ray of light which is away from the normal. And for the third one, again, it's I know it looks almost straight, but it's not. It's going away from the normal. All right. For the third one, the angle of incidence is given as 48 degrees. Now the critical angle of the medium is also given as 48 degrees. So after refraction, the ray of light would basically be passing on the surface of separation. This one is greater than the critical angle. So what will happen is that the angle of there'll be total lateral reflection happening over here. So the incident ray or the ray of light will get reflected back into the same medium. So that is it, guys. That is the answer for this question. Simple as that. Again, it's a 5-mark question, easy peasy in your pockets. Moving on to the last one. Name the phenomena which you see in ray number B and ray number D. Ray B, what you see is refraction, right? Because the ray of light is going from a denser medium to a rarer medium, so you see refraction. Ray D, on the other hand, what you see is total internal reflection, right? Because it's greater than the critical angle, so what you see is total internal reflection. That's it. That is it, people. So yeah, ray B is refraction, ray D is total internal reflection, and by that we have successfully completed yet another SprintX session, another SprintX chapter itself. So refraction of light and plane surface is done and are done, people. So these are all the topics that we've already done. Everything is covered now. Make sure that you watch the previous videos as well, so that you get an idea of what we did in the previous session. This is your homework question taken from 2014 board exam. The question is: light passes through a rectangular glass slab and through a triangular glass prism. In what way does the direction of two emergent beams differ and why? A ray of light passing through a rectangular glass slab and through a triangular glass prism. In what way does the direction of the two emergent beams differ and why would it differ? Let me know what is the answer in the comment section. By the next session, if you want your name to be the homework rockers list, make sure that you hit that like button, subscribe the video, share the video if you can, and also give the answer of this question in the comment section. Right, guys? So that's it from my side. The next session I'll be coming up with is refraction through lenses, which will be coming out on 15th of February. So I hope to see you guys then. Until the next time we meet, this is Anoop signing off the day for today. Have a great evening, people. See you later. And the coupon code is ABPRO. Again, it's valid only for today till 12 p.m. So do not forget to check out the link as well. Thank you for joining. See you guys in the next one. Take care. Stay safe. Bye bye. See you all, guys. Take care.